All right, good afternoon. Here we go. Today is 1.15 day 2. It's a delta math, and the quadratic formula is what we're doing. And the formula, if you are in ax squared plus bx plus c equal to 0.
I don't think you're
I am. Are you leaving?
No, I'm leaving, but I grabbed my wrong folder.
Don't worry about it.
Okay.
You're going to leave in 2 minutes anyway.
Look at my book.
All right. So, quiet. That rhymes. Kind of like quiet riot, but quiet. That's pretty funny. Okay. When we have a quadratic that is set equal to 0, we can solve using the quadratic formula. I hate the quadratic formula. I avoid it at all costs. But it is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And you plug it in and simplify. And again, we can get, do you want to go get a drink?
No, I tried that.
Upside down, put it in your mouth, and then put your head between your knees.
It's your diaphragm.
Yeah.
Trust me,
Yeah.
I've tried so many
Yeah.
things.
Give it a try. We're going to see if it works. All right, put your head down. There you go. Now swallow. You guys enjoy. Thank you. Thank you very much. Okay, see you later.
Yes, because the free deal or whatever. Yeah.
Okay. So on this first one here, I need to move the 10K. I don't really want, can I move the other two terms over? Yeah, I want to do that because I would rather have positive things. Just makes life a little bit easier. So moving those over. So then we have the A, and what we want to understand is that the A is the number in front of the variable squared, and the B is the number in front of the variable, and then the C is the constant term. So please don't put variables in your quadratic formula. That would not work for you. So your quadratic formula should always just be numbers. So this is solving not for x, but we're solving for k-intercepts in this particular case. And so when I sing the quadratic formula, I always say the opposite of b. What is the opposite of b? Negative 10 plus or minus the square root of b squared. What is b squared? 100. Minus 4ac. Now I do a times c in my head so that I have less to write down. So a times c is 8. 8 times 1, just 8. So do some of the math in your brain, makes life easier. And then in the denominator, 2 times a. So that's going to be 2 times 1. 2 times 1 is just 2. So again, do as much in your head as you can. Negative 10 plus or minus the square root of. This is going to be 100. 100 minus 32 is 68. Over 2. Now, 68 cleans up. 68 turns out to be 17 times 4. And so how does that radical simplify? 2 escapes. The square root of 4 is 2, so a 2 escapes. So we get k equals negative 10 plus or minus the 2 escapes, and the 17 has to stay behind. Is that right? That seems too big. Hold on. Hold on. 68 divided by 4. It's 17. Oh, that's right. Okay. All right, over 2. And then what is this 2 dividing? Yeah, it's dividing both terms up top. So the easiest way to always get it right is to split that 2 up so you're dividing both pieces. And then so negative 10 divided by 2 is negative 5 plus or minus. And then here the 2's reduce and you just get radical 17. So negative 5 plus or minus radical 17 is a fantastic answer. Negative 5 plus radical 17, negative 5 minus radical 17. Okay? Questions on that one? Pretty easy. All right, number 14 again, I'm going to move a couple of terms over. So I have 6x squared minus 3x plus 9 is equal to 0. And that's going to give me an a b of negative 3, and a c of 9. So again, a, b, and c are just the coefficients, not the variable. On this one, we are solving for x. So x equals, what's the opposite of b? Positive 3. Plus or minus the square root of b squared. Yeah, if I were to write it down. But b squared would be negative 3 times negative 3, which is positive 9. That is the most common mistake. This really is negative 3 quantity squared, which means negative 3 times negative 3. B squared should always be the positive number. Okay, so we get 9. B squared minus 4 times a times c. A times c is 54. All over 2a, 2 times 6, 12. So I'm just going to write down 12, which is totally fine. All right, I don't know what that is. I'm going to write it over here to the side. 3 plus or minus the square root of 9 minus 4 times 54. I don't know. 9 minus 4 times 54, negative 207 is under the radical there, all divided by 12. All right, 207. 207, that is a crazy number. Ooh, is it divisible by 9? 207 divided by 9. Oh, it is. How did I know it was divisible by 9? So, how do you know something's divisible by 3? Do you know that trick? So that 27 gets you to 207? So to know, for 3s, to know if it's divisible by 3, so yeah, so like for instance, 57 is divisible by 57 is divisible by 3. If you add the digits, you get 12, and 12 divides evenly by 3, so then 57 divides by 3.
So then 207 would be 9 divided by 3 gets 3.
Yeah, so 207, so 9 is very similar. If your digits, now it's not exclusive like the 3 is. If your digits add up to a 9, a multiple of 9, then you know it's divisible by 9 in sort of the same way. So it is divisible by 9. Let's see, it was 9 times 23, so negative 1 times 9 times 23 is that negative 207. And so how would we clean that up? Okay, yeah, so the I comes out from that negative 1, the 3 comes out from the 9. So 3I, radical 23 stays behind, and each of those are getting divided by 12. Split it up, divide and conquer, I like to say. 3 over 12 becomes what? 1/4. We can divide top and bottom by 3. And then plus or minus, and again, 3 and 12 become a 1 and a 4. So I radical 23 over 4. So you can write it that way, which is a great answer. All right. Okay, last thing here, application problem. Quadratics are lovely for physics. A rocket is launched upward with an initial speed of 325 feet per second. And you can see that number reflected right here. This is the velocity, negative 16. Yeah, you did this in physics. That's acceleration due to gravity. Okay. So this is velocity, 325 feet per second. Its path is modeled by the equation h equals negative 16 t squared plus 325 t, where h is the height of the rocket. So h is the height of the rocket. That is how high it's going. And t is time modeled in seconds. And so we get this height of the rocket over time, something like that shape there, okay? And how long does it take the rocket to reach the ground? What does it mean to reach the ground? Yeah, that is a height equal to 0. So that's what we're trying to find. To reach the ground, we want to know when did it take off and when did it land. So to reach the ground is where a height would equal 0 feet off the ground. So we are going to replace the h with a 0. Negative 16t squared plus 325t. I don't want to solve this using the quadratic formula, do you? No, I don't want to use the quadratic formula. GCF would be way better. Greatest common factor is totally the easier way to go here. What do they have in common? A t. I can just take out a t if I want. I would take out a negative t, that'll work. That's going to give me 16t plus 325. And if I'm doing that, I'm going to set each thing equal to 0. So I have negative t equals 0, which means 0 seconds. So that's the launch. So at 0 seconds, it launched into the air. And then here, 16t plus 325 gets set equal to 0. So I'd have to subtract 325 and then divide by 16. And 325 divided by, oh, that's weird. Oh, I didn't change my sign. That's why. That's wrong. That should be positive. There we go. I made a mistake. There we go. If I factor out my negative, my sign is going to change. Negative t times negative 325 gets me that positive. I was like, that doesn't make sense. 325 divided by 16 gives me 20.3-ish seconds. Where it lands. 20 seconds of airtime is pretty good. Okay. That's it for me. Any questions? All right, you got a Delta Math to work on this weekend. Sweet. So it was a good day for this lesson. I'm glad I rearranged. That was 10 minutes.